The first step in any type of PV system design is the analysis of the load demand. In this video, we shall focus on the load analysis. A thorough load analysis will lead to an optimal PV system design. In this video, you will learn about some common types of loads and their load profiles. We will look into the different time scales that one can consider when analyzing a load. Finally, we will accurately determine the total load demand in terms of the daily energy requirements. First, we will take a step back and look at the load table, which we have introduced earlier in this section. A load table basically contains information about the different loads that will be powered by the PV system. The load table contains information on the type of devices used, their rated power, and the number of hours they are operational during a 24-hour time period. If a certain load is used only a few times a week rather than every day, then their equivalent daily energy use should be determined. Let's consider, for example, a washing machine in a typical household. We assume that it is operated 4 times a week and consumes about 375 watt-hours of energy for each operation. To obtain the equivalent daily energy use, we multiply 4 by 375 watt-hours and divide it by 7 days. This corresponds to a daily energy use of 214 watt-hours. If the exact power consumption of a load cannot be found, an educated guess will suffice. A load table analysis is only useful when carrying out a quick and simple PV system design. Advanced PV system modeling requires a more advanced load analysis. This is called the load profile analysis, which we will now discuss. Let's start by understanding what a load profile actually means. A load profile is a graph that displays the electrical power consumption of a load over a certain period of time. We can classify loads in several different ways, depending on their load profile. Shown here, for example, is the load profile of a simple load. A simple load consumes a constant amount of power over a period of time. However, many loads do not have a constant power consumption, but instead show momentary peaks during their operation. Such a peak generally occurs when the load is being switched on or off. In addition to knowing the load profiles of the different loads, it is also important to know their time of operation during the day. In a typical household, for example, there are various types of loads. These loads can operate at the same time or at different times during the day. So when analyzing the load profiles, we should also consider the time at which the different loads are operated. By obtaining the load profiles, we can simulate the behavior of the loads that are connected to the PV system. Let's look at another example to clearly understand the purpose of a load profile. This is an approximate load profile of an electric bike charging station, where a certain number of e-bikes are being charged at different times during the day. You can see that the load demand of this charging station fluctuates throughout the day. There is a high demand for charging e-bikes during the morning and evening hours. Also, there are periods in the afternoon time where the charging station does not deliver any power. Some important information can be extracted from this load profile. In addition to the instantaneous power of the operating load, the maximum power consumed by the load during the day can also be obtained. Furthermore, later in this video, we will also determine the total energy consumption of loads over a certain period of time from a load profile. In PV system design, load profile analysis will often depend on the available resources. Analyzing a load profile can be performed with the increasing complexity and accuracy. The simplest model is to determine the load profile over a 24-hour load cycle and assume the load profile is the same every day. This can be achieved by monitoring the electricity consumption for an arbitrary day. However, such analysis might not include all the available loads, as it might not take into account the loads that are not operated every day. Typical examples are, of course, the washing machine and the dryer machine in a typical household. When such loads are present, a weekly load analysis will give a more accurate result. Additionally, when seasonal loads are present, such as air conditioners or heaters, seasonal load monitoring is ideally preferred. Naturally, the most accurate analysis will be provided by looking at load profiles every day for a whole year. Generally, such a detailed load analysis will be difficult due to time and resource constraints. Hence, a general assumption could be to replicate the daily or weekly load analysis for a whole year. The load profile shown here, for example, is obtained by analyzing the load consumption in 1 week. The analysis is performed 4 times per year, once in winter, spring, summer, and in the autumn. The 1-week load analysis is then used for all the weeks of that respective season. In this way, a full year load profile is obtained. In this load profile, the seasonal variation during the year is clearly visible. Finally, after obtaining a load profile of all the loads connected to a PV system, the total energy demand of a period of time can be determined. It is calculated by integrating the instantaneous power of the loads over the considered time period. The equation shown here considers the load demand of a full year. This is an important parameter in PV system design, which will be used again in other videos. The total load demand is expressed in watt-hour per year. To conclude, in this video we discussed the load profiles and learned how to use these profiles to analyze the load demand, and we also considered the daily, weekly, and seasonal timescales that can be used for load analysis. Finally, we determined the total annual energy demand of our loads connected to a PV system.